Hey Math 1, here are the new skills that we're talking about in lesson 1.2. Remember that there was a video on how to do the prerequisite skills, the stuff you need to be able to have some success in this lesson. So the new skills are being able to convert a decimal like that or a fraction like that into a square root. All right, without a calculator. And the expectation is if I give you any two numbers to compare, be it a fraction with a fraction, a decimal with a decimal with a fraction, a decimal with a square root, or a fraction with a square root, you can tell me, hey, which one's bigger? So, before we do that, how are you supposed to turn 4.3 into root 18.49? Well, I think, a good place to start with this is just to say, how would you turn maybe not even a decimal into a square root, but just a whole number? For instance, like if we have the number 4, okay? There. I mean, what does that equal as a square root? So here's the thing. The better question you should ask yourself is, the square root of what gives me 14? And in order to come up with a right understanding of that, you got to know what it means to be a square root. It means that the output of a square root is that number times itself. 4 converted to a square root is 16. Okay? So, if I had, let's say, 7, it converted into a square root is 7 times 7. It's 49. Or like 11. You're just taking 11 times 11 to convert it into a square root. 11 times 11 is 121. All right, so I'm hoping the wheels are starting to turn now so that you look at a decimal like 4.3 and you just say, hey, I got to multiply 4.3 times 4.3 in order to convert that into root 18.49. So, when you take 4.3 times 4.3, remember to carry that 0 down because this 3 now is kind of acting as a placeholder 0 for 16, Adam, and then 2 decimal spots. Remember, that means 2 decimals in. That's where the 18.49 comes from. So when you do this work, it culminates into 4.3 equals root 18.49. So that's all it is. When you need to turn something into a decimal, you multiply it by itself. Let's check out the fraction. So to turn a decimal into a root, you multiply it by itself. A whole number into a root, you multiply it by itself. A fraction, you multiply it by itself. We talked in the other video about how you multiply top times top, bottom times bottom to make that happen. And we also talked about how to turn it into a mixed number. 9 goes into 64 7 times. And then 9 times 7 is 63. The difference is 1. That's where that extra spot comes in. Bingo, that's the work that's required to make this happen. Now, I would expect you guys, if you have bigger fractions like, say, 72 over 5, that you would show me 72 times 72. Show me the work that makes that happen. So yeah, that's the new skill. Not too bad if you know how to multiply and do all those pre-algebra skills. And then here's kind of the where this is all building towards. So we're trying to figure out which of these numbers is bigger, 0.8 or 31 over 35. So I put two boxes for whatever work you might need to do on this notes sheet, but just for the sake of simplicity, I'm going to do the work in this one box here. Because I don't think it's all going to fit on the screen unless I zoom out. Yeah. So 0.8 versus 31 over 35. So we just need a common language between those two. Like when you're converting, when you're trying to compare a square root to a non-root, it makes sense that we turn them both into square roots because then it's like, I'm just looking at a number compared to a number. These two need to also be in the same language. So I can either convert the fraction to a decimal or convert the decimal to a fraction. In this case, I'm just going to choose to turn 31 over 35 into a decimal that I can compare to 0.8. Because it's probably either going to be 0.7 something, 0.8 something, maybe 0.9 something. So 35, here, just ask yourself the question, does 35 go into 310 8 times? So we're making that guess. 8 times 5 is 40. Carry the 4. 8 times 3 is 24, plus 4 is 28. Oh, definitely. Subtract the 2. Drop another 0. And here's the thing. This is 0.8, and it's implied that it's 0.80 because there's nothing after it. Well, this is definitely going to be 0.8 something more, right? It's going to be 0.8 either 7 or 8. I'm guessing it's going to be 8 again, right? Because 280 was the 8 times 350 was 280. So you do 8 times 30, 35, not 350. Yeah. Okay. Talking too much. I think this speaks volumes about what's happening. 31 over 35 is approximately 0.88. There's more decimal stuff happening outside of that, but I've got a digit of accuracy that can actually compare these properly. So this one is bigger than 0.80, or 0.8 is less than 31 over 35. All right, so make sure you're able to do that. I mean, you could have done the whole convert the decimal into a fraction like this. So 8/10 is 8 over 10 versus 31 over 35. But at that point, you'd have to find a common denominator between the two. And, well, you know what? I can do that. 8 over 10 is the same as 4/5 if you reduce the fraction. So if you wanted a common denominator of 35, you just multiply this by 7. So 8 over 10 is the same as 28 over 35. You would have come up with the same conclusion there. It was just a completely different way of approaching that. All right, let's talk about example number 2. Example number 2 asks you to convert the decimal 3.17, or I'm sorry, it asks you to compare 3.17 to root 10. Now again, over here we said that the common language we established was either fractions or decimals. We went decimals to start with, and then I confirmed it with the fraction. The common language between these two, you're not going to figure out what root 10 is exactly as a decimal because it's a never-ending decimal that doesn't have a repeating pattern to it. So it's literally impossible to convert that root 10 to a decimal, like totally. You could convert root 10 by guessing and checking, but it just makes so much more sense to say, I know how to turn that 3.17 into a root. You take it by itself, multiply, that's what the root is. So we have to take 3.17 times itself. So pause the video and see if you can multiply that out on your own. All right, you've unpaused it. Let's confirm or see if you made a mistake. So 7 times 7 is 49. Carry the 4 is 11, right? 7 times 1 plus 4 is 11. Carry a 1. 21 plus 1 is 22. All right, now I ignore the 7 with a 0 placeholder. 7, 1, 3. Now I ignore both of those digits with 2 zeros as placeholders. 3 times 7 is 21. 3 times 1 is 3 plus the 2 is 5. That carried over, and then 9 here. All right, so you got 9, 8, 4. 8 plus 0 is 10, with a 1 left over here. So you got 10, 0, 4, 8, 9. Remember, 2 decimal. That means there's going to be 4 digits that need to move. Which makes sense. 3 times 3 is 9. It would be 10 point something and not 100 point something. So here's what I want you to show in the box when you're multiplying these out. I want you to just show it's 3.17 is equal to root 10.0489. That just shows me that you understand that you're not just like making random calculations and have no clue what you're talking about. It's like you did a conversion, which means that that is bigger than the 10. All right, so now we've got a fraction and a mixed number. You know what? I think I'm just going to start a new video to make sure we have enough time to do those.